This video is a quick refresher on scientific notation. So in this class, we're going to deal with real world numbers. And sometimes those numbers are going to be really, really big, like we'll see in section 3b when we talk about energy conversion. And sometimes the numbers will be really, really tiny, like we'll see when we calculate probabilities of winning the lottery. And when we have these really big numbers or really small numbers, scientific notation is like a shorthand, condensed way to express that amount. So let's look at an example of a big number. Our national deficit is huge, y'all. It's $26.9 trillion. When I expand that number out, I can see that's a whole bunch of zeros, right? That's a big number. Now in scientific notation, I would only have to write 2.69 times 10 to the 13th. Much more condensed version of that amount. Now let's look at a really small number, like the probability of winning the Mega Millions lottery. Well, you have about a 1 in 300 million chance of that happening. So if I take 1 and I divide by 300 million, we get this little bitty decimal number there. And in scientific notation, that would be expressed as 3.3 times 10 to the negative 9. Okay, so what do these two values that are written in scientific notation have in common? What does it mean to be written in scientific notation? Well, both of these amounts have a power of 10. So if an amount is expressed in scientific notation, it's a power of 10. And both of them have a decimal number in front of that power of 10. And it's not just any old decimal number. It's a decimal number where there is exactly one digit in front of the decimal, and that digit is not 0. So for an amount to be written in scientific notation, there's two conditions. It needs to be a power of 10. So you have to see times 10 to some exponent in there somewhere. And the number in front of that power of 10 can only have one digit in front of the decimal, and the digit in front of the decimal can't be 0. So basically, the number in front of the power of 10 is a number, a one-digit number between 1, and it can include 1, and it has to be less than 10. And I can see that down here on this probability example, 3.3, that's a number between 1 and 10, right? And when I locate the decimal, there was exactly one digit in front of that decimal number, and it wasn't a 0. So both of these numbers are written in scientific notation. Something else to note are the exponents on those powers of 10. When I was dealing with a really, really big number like 26.9 trillion, the exponent was positive. And when I was expressing a really, really small amount, the exponent was negative. Okay, so let's talk a little bit more about those exponents. Where did this 13, this positive 13 exponent come from? Well, when I take this big expanded number and I locate its decimal, well, there's none written, so it's located at the end of the number, I need to relocate that decimal. I need to move it, in this case to the right, until there is exactly one digit in front of the decimal, and that digit is not 0. So when I do that, I'm going to end up moving my decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 place values. And we have a base 10 number system. So if I relocate that decimal point 13 place values, that's the same as multiplying by a power of 13. And since my original number was a large number, it's a positive 13. And where did this negative 9 come from in the smaller number? Well, in the original, in the expanded small amount, the decimal is written for me there, and I'm going to relocate it. I need to move it, in this case, to the right until there's exactly one digit in front of the decimal, and that digit is not 0. So when I do that, I'm going to relocate it 1, 2, 3, 4, 5, 6, 7, 8, 9 place values. That's why my exponent was a 9, but it was negative because that original amount is a small amount. It's technically smaller than 1. So our power of 10 will have a negative exponent. Let's try some more examples. Let's practice converting these two amounts into scientific notation. So go ahead and pause the video, give these a try. When you're done, unpause and see if you got them right. Okay, let's look at number 1. This is a little bitty decimal number, right? Way less than 1. So I know my power of 10 is going to be times 10 to the negative something. And I'm going to move my decimal place to figure out what the exponent is. So I see my decimal typed in that number for me. I'm going to relocate it. I'm going to move to the right. 1, 2, 3, 4, 5, 6 place values. So my exponent is going to be a negative 6. And the decimal number that I created was 5.09. So I can rewrite that decimal number as 5.09 times 10 to the negative 6. Now that's in scientific notation. And it's in scientific notation because it's a power of 10. And then the decimal number is written with exactly 1 digit in front of the decimal, and that digit is not 0. Okay, what about this next one? Let's see how you did. There's no decimal written in number 2, so it's understood to be at the end of the number, and I'm going to relocate the decimal by going to the left. 1, 2, 3, 4, 5, 6 place values. And since this was a big number to start with, it was 7 million, that's going to be times 10 to the positive 6. And then I can either just write a 7 there, 7 times 10 to the 6, or if I want to write the decimal, I can write 7.0 there. I like to write the decimal, but you don't have to. Okay, so let's go the other direction now. So in these problems, you're given the scientific notation and you're being asked to expand it out. So again, pause your video. When you're done, unpause and see how you did. Okay, let's look at number 3. On number 3, I see a power of 10 with a positive exponent. So I know that my expanded number is going to be bigger than 1. It's going to be a big number. So I'm going to write down my 9.2 here. I'm going to locate my decimal. It's written there for me. And to make 9.2 a larger number, I need to push my place values. I need to move my decimal to the right. And I'm going to move it 8 place values. So that's 1, 2, 3, 4, 5, 6, 7, 8. So my decimal will be right there. And these missing place values, I'm just going to fill those in with zeros. So when I expand this number out, I'm going to have 9, 2, and 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay, so that was 920 million. What about number 4? So I'm going to take 4, and there's an understood decimal after the 4. And I see that my power of 10 has a negative exponent. So when I expand this number out, I'm going to get a number smaller than 1. And to make that happen, I need to move my decimal to the left. So I'm going to relocate it 5 place values to the left. 1, 2, 3, 4, 5. Again, I'll fill in those missing place values with zeros. So my expanded number is decimal 0.00004, and you can write a 0 in front of that decimal place if you would like to. Okay, there's one more thing we need to talk about in this video, and that is translating common place values into powers of 10. So we're going to be dealing with big numbers in section 3B, and you might see words like thousand or million or billion or trillion. So we're going to convert those place value words into powers of 10. So let's look at some examples. Let's look at number 6. There are approximately 2.2 million marriages per year. 2.2 million marriages per year in the United States. So if I want to take 2.2 million and rewrite it as a power of 10, I'm going to write that 2.2 times 10 to the, looking up here, times 10 to the 6th. So 1 million translates to times 10 to the 6th power. And then we're asked, is that amount written in scientific notation? So let's just check it out. Let's see if it is. I have a power of 10, so that part's correct. I have a decimal number, okay, and I locate the decimal. Is there exactly 1 non-zero digit in front of the decimal? So exactly 1 digit in front of the decimal, and that digit is not a 0? Yep, okay, so yes, this is in scientific notation. Now let's try this next one. B. B says the estimated world nuclear energy production is 2,608 billion kilowatt hours. So if I want to take 2,608 billion and rewrite that as a power of 10, I'm going to have 2,608, and I'm coming up here, billion is times 10 to the 9. So times 10 to the 9. Okay, those are equivalent. And I can calculate with this 2,608 times 10 to the 9. I can put that in my calculator, and we'll practice that in class, or you can come to office hours. But that number is not in scientific notation. So you can totally use it while you're calculating, but if you're asked to write a final answer in scientific notation, you could not enter 2,608 times 10 to the 9th. It's not in scientific notation because there is a power of 10. I mean, that part's okay, right? So, but the other condition is the decimal number, or the decimal is located after that 8. There's 1, 2, 3, 4 digits in front of the decimal. We need exactly 1 digit in front of the decimal, right? And that digit can't be 0. So this is not in scientific notation. So let's practice writing that in scientific notation. So 2,608 times 10 to the 9th. I'm locating that decimal. Okay, now there's lots of ways to do this. I'm going to do the long way here. I'm going to just expand this out into the decimal form. So to do that, my power of 10 is 9. That means this is a big number, so I need to move my decimal to make this number bigger. So let me go ahead and do that. So I'm going to write out my number. I'm going to relocate the decimal 9 place values. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my gosh, my decimal really should go here. And I'll fill those place values in with zeros. Oh my gosh. Okay, that is a huge number, right? And then now that I have it expanded out, now I can rewrite it in scientific notation. So I'm going to have 2.608 times 10 to the what? Let's see. Let's relocate that decimal point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I needed to relocate that decimal 12 place values. So we rewrote our amount in scientific notation the long way, right? We took the non-scientific notation power of 10, I expanded it out, and then I rewrote it in scientific notation, which is 100% okay. But there's another way to think about it. You can think about this. You can think about, okay, here's my decimal in the number I'm given. It's behind the 8, right? I need to push it 1, 2, 3 place values to get the decimal in the right location, right? So when I'm pushing that decimal, I'm taking 2,608 and I'm changing it to 2 and 608 thousandths, right? So I'm making the decimal number seem smaller, so I have to increase the power of 10. If I move the place value 3 place values smaller, I need to make the power of 10 3 powers of 10 bigger. So I'm kind of balancing it out there. So if I had it to the 9th power and I move my decimal 3 place value smaller, I make the power of 10 3 place values bigger, which would be a 12. But the safe way is just expand it out, right? And then just rewrite it, as long as it's reasonable, as long as it's like not times 10 to the 30th, where you have to write out 30 numbers. You can also type that original amount in your calculator. And then when you press enter, most calculators are programmed to automatically reduce that to scientific notation. But sometimes numbers are so big it'll overflow a calculator. So you just have to be careful. Okay, so we're going to hit the ground running with section 3B in class. And you're going to see numbers written in scientific notation. So make sure you work the short scientific notation My Math Lab assignment just to practice, especially just practice using your calculator, right? Finding all these buttons and things on your calculator and being able to go back and forth between scientific notation and the decimal number and vice versa. And if you're really feeling like, whoa, what just happened? You can come to office hours to get help on scientific notation, or you can visit our instructional associates or embedded tutor or one of the tutors at the Learning Lab. The assignment on My Math Lab also has a lot of help tools built in. So scientific notation, be prepared for section 3B.